All right, so let's just start with the problem statement first. For threads and synchronization, you have a new setup for TAs where they want you to implement a new paradigm for office hours. So every time you walk into the room, you would have a table with several pens and notebooks, and this is what you're supposed to do with them. You're gonna wait until you're called, and then you claim a pen and a notebook. Then you use the pen to write down your question on the notebook. And after you're done writing the question, you release the pen. Then you grab a notebook and wait for until the TA is able to help you. Hold the notebook, and after you're done talking to the TA wants you to write down the solution again on the notebook just to be sure that you've understood the concept. Once you're done doing that, you release the notebook, you release the pen, and then you go home. Sounds simple, right? So now, as you can see, there are several resources here. One, you have the notebooks. Two, the pens. The TAs can be considered a resource here. And the students are definitely on this form of resource. Now, how do you manage all these resources in a way such that they don't get deadlocked with each other? So you need to kind of implement an algorithm using locks and make sure that they do not deadlock. So this is kind of a typical code that we're going to use for it. So we have a main function which essentially just launches a few threads. So what it does is it initializes with standard setup, say where you have 5 pens, 5 notebooks, 3 TAs, and 50 students. And then, so what it does is essentially creates some 50 threads representing all those 50 students, launches them, and waits for them to kind of get done. So this is pretty straightforward and simple like that. So what happened was a student wrote some code for it, for the worker thread, because that's the main part we'll be focusing on. And turns out that it works fine most of the time, but there is a deadlock once in a while. So the question here is, what exactly is causing the deadlock? Is it A, the deadlock is caused by the pen and the notebook? B, is the deadlock caused between the notebook and the TA? Or is it C, the deadlock is caused between the TA and the pen? So I'd give you guys a moment to think about it, and then you can tell me what do you think, and we'd go over a few examples out what might happen in each case. All right, does anybody have an answer? Anybody? Yeah.
Raise your hand if you think it's A.
Okay.
Raise your hand if you think it's B. And how about C?
No.
And I guess everyone else doesn't know.
All right.
Let's find out.
All right, so like I said, you have 5 pens, 5 notebooks, you have 3 TAs and 50 students. I'm sorry, it just got deleted. Okay, let's just consider the case C, where you're analyzing the deadlock between pens and TAs. So as you can see, you take a lock on the pen there and you give it up. And then you get a lock on the TA and you give up the TA, and you get a lock on the pen and give the pen here. So technically there's no overlap here. So what that means is there cannot be a case where a student who is talking to a TA is waiting on a pen, and vice versa. So what that means is a student who is holding a pen will not be waiting on a TA either. So they cannot kind of deadlock each other, right? Let's take a look at case B. So there is an overlap here between the TAs and the notebooks. A student who is holding a notebook may be waiting for a TA, but a student who is talking to a TA will not be waiting on a notebook. He would already have the notebook, right? So again, they cannot deadlock. But what about case A? There is an overlap, yes. And so it turns out the student who is holding a notebook may be waiting on a pen. And a student who is holding a pen may be waiting on a notebook. Now, like I said, there are enough resources. There are 5 pens and 5 notebooks. So in most cases, that probably would not get stuck. But let's consider a case where you have 5 students who walk into a room and they grab all the pens and they grab all the notebooks. And then there are other 5 students just waiting behind them to grab the pens. So these 5 students, they give up the pen and wait on a TA. And while they're doing that, the other 5 students who came in behind them get all the pens. Now, after talking to the TA, they need the pen to write something on the paper again, right? So now they cannot get the pen because the other 5 students have taken it, and those 5 students have taken the pens, are waiting on the notebook, which these 5 people hold. So they kind of are waiting on each other, and no one can move forward. Does this make sense to everybody? Do you want me to go over this again? One more time? Okay. So let's just consider a case where you have 5 students who walk into the class. They grab all the 5 pens and all the 5 notebooks. Now, after writing down the question, these 5 students are waiting on the TAs. So they give up the pens. The 5 pens that they have given up are grabbed by the next 5 students who have now taken the pens but are waiting on the notebooks. Now, after consulting the TA for some time, these students, they need the pens again. So they need 5 pens, which are being held by 5 other students who are waiting on the notebook. And these are 5 students here who have the notebook but are waiting on the pen. So they're kind of waiting on each other. And in that way, no one can proceed forward. So you have a deadlock there. So it's answer A. The answer is option A. That is, a deadlock can be caused between the pens and the notebooks. Yeah.
So what would be a fix for this problem?
Yeah, that's the next part of the problem. All right. So is there a way we can fix this problem without changing the procedure?
Yeah.
Anyone? Yeah.
Should pick the notebook for the whole.
Yes. So you basically reorder the locks in a way. So if we grab the notebook first and then grab the pen and maintain the reverse order here while we're releasing it, things do overlap to an extent, but they're fairly simple. So if you do that, if you grab the notebook before you take a pen and you release the pen first and then the notebook, then you would have a condition where there won't be a condition where a student who is holding a pen will already have a notebook, right, up there. And a student who is talking to a TA will already have a notebook and hence will not be waiting on the pen. So if you have locks like this, you won't have a student who is waiting on a notebook, who is holding a notebook but is waiting on a pen, right? So that's kind of about it, and that was a simple question at that. But you'll be getting different variants of this particular questions in your exam, and it should be pretty straightforward and simple if you can get this one pretty easily. Yeah.
So can we say that when there is an overlap, we have to make sure that the locks are in the same order?
So the overlap is not necessarily a condition. It's just like kind of an indicator for you to analyze the situation. So when if ever you see an overlap there, you just say, for example, if I'm talking about this lock, so you just come here and analyze what are the different things that can be waiting on it, or what are the different things it is waiting on before coming to this particular statement. And that's how you can analyze it. Yeah.
Can we accept that kind of as a rule that if we do mirror unlocking as we did locking, we won't have a deadlock, or is that not safe to assume?
Typically, in a lot of cases, you have this thing called ordering of locks. So you grab like you kind of have a priority of locks in your head. You grab a lock first and then the other, and if you maintain that ordering every time, you're not guaranteed to not have a deadlock, but you tend to prevent deadlocks from happening.